Hey, but you know how to do this. Look at guys. 8 times D. Back to 8.3. Okay. Number 10. Yes. There you go. Number 10, you were just multiplying, right? And the answer was yes, because whether you multiplied A times B or B times A, it's the identity. Number 18, you were setting up the matrix with the identity matrix and row reducing with an easy one, showing that it worked. The inverse ends up being 1, 1, 3, 4. Number 20, all of a sudden, even the formula shortcut won't work. So then you had to do the 3 by 3 with the identity, row reduce it, and hopefully if you did it correctly, you'd end up with the inverse. Kiddos, even on the evens, couldn't you have checked with your calculator? Just an idea if you didn't already think about it, but most of you did. Hopefully in a way that you still completed homework with integrity. Anyway, number 40. Determinant of that 2 by 2 ends up being negative 143 over 36, which means, yes, there is an inverse. When is there not an inverse? When the determinant is 0. Good. With the determinant 0, we can just stop. But since there was a determinant, cool. Do 1 over that times, remember? Flip the main, or maybe switch the main, opposite the opposite. So switch the main, opposite signs of the opposite diagonal, bring it on in, and you got it. Number 50. Find the inverse function. Since it's a 2 by 2, they say, cool, use the shortcut, no big dealio. Once you have the shortcut, multiply that inverse by the constants, and you have the final solutions of 1/2, 1/3. I know number 50, you could have used substitution, elimination, row echelon form, reduced row echelon form, but we were just showing you can also use inverse matrices. Find the inverse, multiply by the constants, done. Okay, anything that you guys in your groups, now that we've checked the evens or remaining from the odds, that you guys want to ask? Go team. All right, 8-4. Here we go. 8-4 is all about, oh, that's not you guys. Sorry, go away. That's you guys. Do you want to? Inequalities. We'd be going on to the linear programming, aka the constraints and the objective functions, and the word problems with the Model A, Model B cars. Okay, all right. Yeah. It's not fully determined. It kind of depends on how many kids we have and who's already full or not full with their schedules. No, we've actually opened it up at all the departments since statistics applies to psychology. It applies to all the sciences. It applies to history a little bit more, like econ and government. I mean, it applies in every single field in some way, shape, or form. English, but psychology, the soft sciences. Anyway, so we have multiple people that could be qualified and could be interested. I know, right? Wouldn't that be cool? But she already has, like, her poor little biotech where people just take it just to have her but not to have to work. I don't think she wants another one. That's one of the hardest classes for her to teach, even though it's super interesting, but people don't take it seriously, which is sad. Okay. You guys ready? Determinant. Haven't we already talked about the determinant of a little baby 2 by 2? Okay. I think the section does, though. 3 by 3, 4 by 4, 5 by 5. Now, the determinant of a 2 by 2. This formula only works with a 2 by 2 because how many entries are there? Yeah, A and D and B and C. This whole formula is based on there being only 4 entries, so it only works for a 2 by 2. We're going to see a process that only works for a 3 by 3. And then we're going to see the general way of finding the determinant of any sized square matrix. Square matrix. Wait a minute. Didn't we just talk about square matrices yesterday? Why was it so important that the section title of 8.3 was inverses of a square matrix? Yeah, it's only possible. It's only possible with a square matrix. So every square matrix has an inverse? No. But only square matrices are possibly invertible. Possibly non-singular. That's kind of awkward, but possibly invertible. 8.4, every square matrix does have a determinant. But depending on the determinant's value, well, if it's 0, we already know no. Don't even go looking for an inverse if it's something else. All right, there is one. Let's go find it. There's some notation for determinants. I don't know why I'm holding the remote. I used it and I just didn't put it down. One way of showing a determinant is with brackets, kind of like you see up above around the matrix, which is always around the matrices. But if you put a bracket around the name, that could be showing determinant. If you do, like I showed yesterday, the DET of matrix A, I think your calculator has that maybe under the matrix map menu. I think. D. Ooh. Hold on, there is a third way. But that third way is making me question my first way. I think it's absolute value. Around the matrix itself, if you see absolute value, if the brackets aren't closed, that's going to be referring to a determinant, which makes me think, struggle. Not brackets around matrix A, it might be absolute values. It is. Struggle. That's okay, that makes more sense with the third notation. It's not brackets, it's absolute value bars. Once again, not that it means absolute value, that's just what you guys are most used to using those for. But if you have absolute values around a matrix, we're looking for the determinant. It could also be around the entire matrix itself, not just the name, determinant, or DET is the most commonly used one for determinant of A. Okay, so we did this yesterday, not a big deal, right? Ready, set, go. Main minus opposite. AD minus BC. Main minus opposite. Oh, that's where main opposite came from. Main minus opposite. But the determinants are only easy on the easiest ones, aka the 2x2s. There is a process that we'll get to. We'll see a trick for a 3x3 that can work, but it doesn't apply to any higher, so it's kind of a bummer, but it could make the 3 a little bit easier. The trick for the 3x3 is building off the trick of the 2x2, kind of, but then it's just a null and void for 4, 5, and 6. The ones for 4, 5, and 6, there's not really a purpose to go back. For 2x2s, we'll just be using this formula. There's not really any other reason to do it any other way. Do you guys get 7? Pause, let's label them. Because it's 2 times 2 minus negative 3 times 1. So 4 minus negative 3, 7, yeah? 4 minus negative 3, yeah. For letter B, if I'm trying to find the determinant, I'll just use all my notations. What'd you guys get? Main, 4, minus opposite. 4 minus 4 is 0. Ooh, what does that mean about this guy? I know they're not asking it, but I am.
DNE.
What's DNE? What does not exist? The determinant does. It's 0. The inverse does not, so we would call this guy singular, aka his inverse does not exist. Letter C. I'll go ahead and use the other notation. If the matrix ever looks or appears in an absolute determinant, this is rarely used, but it could be. What'd you guys get? Negative 3. Good. So, has an inverse, doesn't have an inverse. But the determinants do exist. 7, 0, and negative 3. Are we good? Main minus opposite. Now, other size determinants. Remember I said this whole section is going to expand on the idea of determinants. And yesterday I said a determinant for matrices is like a dot product for vectors. There are lots of applications. We get to start off super easy. Because the determinant of a 1x1 is itself. Oh, Well, that one's kind of lame and boring, but there's nothing really to do to it. The determinant of a 1 by 1 is itself. Kind of like the derivative of e to the x, but that's calculus. Okay, so the determinant of a 1 by 1 is itself. The determinant of a 2 by 2 is main minus opposite. 3 by 3 or higher? All right. I could teach you the method for 3 by 3 or higher right away, or I could show you how there kind of is a way to do a 3 by 3 only using kind of the idea of the 2 by 2 formula. But the sad thing is it doesn't work for 4 by 4s or above. So there is a trick for 3 by 3s, it just doesn't work for anything higher. So eventually we will have to get to a generalized method that will work for all 3 by 3s or above. Thomas asked a second ago, well, once you learn that, can you use that on the 2 by 2s and the 1 by 1s? And my answer was pretty much no. The 1 by 1 is super easy. It's itself. The 2 by 2, use your formula. 3 by 3 or above. All right. So, first of all, this doesn't look fun, does it? Just take it word by word. Take it sentence by sentence. Take it idea by idea. Well, let's see what we need to write. Let's narrow it down, okay? Determinant of a square matrix. What size? I don't care. Anything. 2 by 2 or greater. We're going to basically just use it for 3 by 3s or above. If A is a square matrix, we already know we have to do that. Then the determinant of A is the, okay, here we go. DET of A is the sum of the entries in any row or column. Oh, I get to choose? Huh. Okay. The sum of any row or column, I get to choose, you get to choose, multiplied by their respective cofactors. At this point, you should pause and say, excuse me, what is a... Yeah, what are the respective cofactors? Huh. Respective means like, well, for the first guy, the first one, for the second guy, the second one, for the third one, the third one. Respective just means like an order, which you can kind of see down here, 1, 1, 1, 1, 1, 2, 1, 2. That's respective, but cofactors, well, I think they're those capital C's, but okay, we haven't learned the cofactors yet. This whole idea is finding the determinant by expanding cofactors, and I would probably write down the formula. I don't think you really need anything else. To find the determinant, expanding by cofactors, you're going to take the sum of the entries in any row or column you get to choose, multiplied by their respective cofactors. That's all this math is saying. I don't know, we're adding together things that are being multiplied. Using all the entries in a row or all the entries in a column I get to choose. This just begs the question, what is a cofactor? And we'll talk about that. A couple more seconds to write down what you need, but this does beg the question, what is a cofactor? And we'll talk about that next. P.S. If you guys haven't checked out the backboard, homework's due Friday, which means we're finishing this section tomorrow. However, tomorrow we're also getting a head start on 8.5 as well. I did have someone asking me a second ago about the calendar for honors pre-cal, as far as when a test is coming. P.S. It's not this week, although you should already know that. Our next test is, dun, 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 dun. Well, while it waits, I'll let you keep taking notes. My guess is next, like Wednesday. That's my guess. Maybe Thursday. Well, I should start counting how slow my computer is. Long story short, look at home tonight. Okay, so I tried. It just took forever to load. Cofactors. What on earth are... Okay. Cofactors. To get to those, we have to talk about minors. Not you guys. Ooh, look at you go. With freedom comes great responsibility. Use it wisely. There you go. At least you've thought about it. Not sure that's good or bad. But anyway. Good? Not a lot. Not a lot. You don't have to pay for driver's ed if you don't have your license yet. You get to waste money gambling with the lottery. Good. Take statistics and you'll see how much of a waste the lottery is and how it exploits the poor. It's actually really sad. In the DR, you walk around and you see all these, what are they called? Coffee house? Coffee bank? Something with a coffee bean. You think they're like little coffee houses. You're like, oh, that's so weird. This village that like doesn't even really have running water or barely does has these little like, you know, baby drive-through Starbucks. And you're like, oh, wait, no, this is just where they come and buy into the lottery and waste all their money that they just earned for the day. And their kids are starving. It's pretty rough. Las Vegas is a little different, but the struggle and the dilemma is pretty similar. Not to say that people can't have fun gambling in a recreational way where they don't waste their families' livings, but it is a dangerous thing to start. Isn't that how a lot of life is, guys? We could apply that to Netflix. We could apply that to drinking. We could apply that to so many different areas. To Instagram. To Snapchat. To football. Anyway. Some things are inherently wrong, but some things we just use so unwisely. Gotta beware. MN. The nth row and the nth column. So basically, guys, cofactors are minors with plus or minus signs. And not plus or minus signs like an established positive or negative. That just sounds like plus or minus. Anyway, the main idea of a cofactor is a minor. It's the minor with the appropriate or multiplied by the appropriate sign. Multiplied by a positive or multiplied by a negative. Here's the idea. You just read, as you're writing, you just read how we can find the determinant of any 3 by 3 or above, technically any 2 by 2, but it's kind of awkward if you do it that way, by choosing any row or any column and going through the entries in that row or column and pairing each entry up with its respective cofactor. And it's like, who's a cofactor? Well, hold on, look. If you chose this entry 0, his minor, which is basically the main idea of the cofactor, just the cofactor puts the appropriate sign on as well. 0's minor would be the remaining part of the matrix once 0's row and column is crossed out or ignored. So if you look at a certain entry, if you ignore his row, ignore his column, and look at the remaining entries, that is the minor. And the cofactor says, well, wait. That's the minor? No. The minor says you still have to find the determinant. So you take what's remaining, you find that determinant, that's the minor, then you say, hey, with that minor, either multiply by a positive or a negative depending on where the entry was. So guys, for this one, for the negative 1, 2, 0, 1, in order to find the cofactor for this one up above, cofactor 1, 1 of the given matrix, which is right here, would be the determinant. Well, hold on. Who's the determinant of this guy? Negative 1, right? Minus 0. What's negative 1 minus 0? Okay. So negative 1, but then we have to look at this guy and say, wait, where's the 0? Whatever size matrix it is, it'd be in this spot. But it is a little dangerous because we do have to make sure it matches up. So hold on. going back to the beginning, this is a 3 by 3. Zero's in this spot. Sure, give me a second. Zero's in this spot, so therefore, I'm going to put in front of that -1 a positive. What's a positive times a -1? A -1. Oh, well, then what was the point? What if it was an entry that's here or here? Then the sign would have been a negative, and negative times a -1 would have been a positive 1. I'll zoom in on that little chart of signs at the bottom, but guys, the chart of signs is actually super, super, super easy if you just get the pattern. Well, I don't know if you need to memorize it. What's the pattern? Start with plus and then just alternate. So positive, negative, negative, positive, like just alternate signs. I wouldn't say you need to memorize it. I'd say maybe just write it once for one size matrix and just say, okay, well, if it was bigger, I would just keep alternating, Yeah. You can pick the one in the middle, but you have to pick an entire column or an entire row. So anything you pick is going to have 3. Don't go diagonal. That's a bad idea. But any row or any column. We good? Alternate signs. So a minor, once again, if I was to zoom out. Because once you get the pattern, like you shouldn't be memorizing this. It's just a pattern. A minor says, if you're looking at an entry, trying to do this process of expanding by cofactors, I need an entry times its cofactor plus an entry times its cofactor for everybody in a row or column. Okay, if I choose a row or a column, and if I need to use this 0, so either I'm choosing this guy or I'm choosing that guy, I need his entry, 0, and his cofactor, which says ignore, ignore, take the rest, determinant, go, establish a sign. Whew, that would be this very first piece. Oh, nope, that would be this very first piece times 0 plus. All right, let's keep going. Like anything, we need to practice. Let's practice with something super easy, which we already have a way to do determinants of a 2 by 2, so you're kind of like, well, what's the point? We're just getting the idea with something easy, then we'll expand on it. Okay, M11 says, who am I looking at? Which entry? The first one. So if you look at 0, cross, cross, well, who's left? Oh, and -4 has a determinant of -4. The cofactor would say, hey, the 0 is in what position in this little chart? You guys think about signs. It always starts with a positive and then it alternates, right? Okay, so 0 is in what spot? That spot. So what's a positive times a -4? Okay. So what's going to be the minor for 1, 2? Who am I talking about? Now I'm talking about 10, right? Ignore, ignore. What's left? 3. Any 1 by 1 has a determinant of itself. But what position is it in? Negative. So it's going to be a negative times a positive 3, which is going to be the cofactor is -3. Your turn. Do the next 2. Your turn. Do the next 2. Okay, check in your groups. Do they agree? Everybody's here today, right? Yeah. Do you mind taking that off this one? Thanks, kid. Ooh, it's coming. Have you heard about it? Guys, what's fully easy? There's only one spot. And what's the determinant of that one spot? Itself. Oh, well, that's easy. What's going to make this harder? If it's a 3 by 3, let's just go baby steps. If it's a 3 by 3, why is it harder? When you cancel, what are you going to get left? A 2 by 2. And how do you do that determinant? AD minus BC. It's going to take a little more time than just rewriting it. Does that make sense? It's going to take a little more time than just rewriting it. A positive times 0 is still 0. No big dealio. And then you might think, well, wait, if I have a 4 by 4, oh, what's going to be left then? A 3 by 3. Oh, and I'm going to have to find the determinant of, okay. So, For 2, 1. Sure. It's not so much that we're putting anything there like kind of magically. It's more that we're saying if it's a positive number times a negative one, it will be negative. If it's a if it's a negative number times a negative, it will be positive. Yeah, think of multiplying by a negative like multiplying by a negative 1. Now remember remember when we're talking about matrices and we put absolute value bars, we're not talking about absolute value. What are we actually talking about? Determinants. So back here, this is a determinant, not an absolute value. When I did this, it wasn't an absolute value. It was looking for the determinants. Think about context. Good question, though. Okay, what do you see me doing? Which row am I seemingly choosing to go through? First row. So I'm going to go ahead and take 0 and 2. So who am I going to do here? 1, the third one. But I'm going to do 0, then 2, then 1, right? Ready? Well, let me do the first one. Okay. If we were going to do the determinant, I would need to get, for my formula, A11 times C11 plus A, if I'm choosing the first row, A12 times C12 plus A13 times C13. But in order to plug, I know, my marker is somewhere. He's back here. In order to plug into that formula, well, okay, the A's are easy because, guys, what is A11? No. A11 is 0. It's the first entry in the first row, first column. It's the entry in the first row, first column. Hi. Thanks, Kat. Okay. It's the first entry, first row, first column. What's 1, 2? Yeah. First row, second column. What's A13? Okay, so the A's are just the entries themselves. It's just 0 and 2 and 1. No big dealio. But what do I need to find? The C's. And what does C stand for? Cofactors. Okay, so how would I find C11? Find the minor, which would be, do you guys see it? I already kind of, -1, 2, 0, 1. This denotes that I'm not done yet. I still need to find the determinant, but pause. What sign am I going to attach? I don't want to have to write M's and C's. That's going to take forever. So what sign am I going to attach? Why? Isn't it a positive, negative, positive? This is a 3 by 3. So 0 is going to be a positive. Good. What's my determinant? -1, minus 0. Yeah? So down here, I'm going to say, hey, let's take the 0 and let's multiply him by negative 1. Now, C1, 2. Just so we don't forget, let's start with the sign this time. Negative because of its placement, right? Okay, so I'm putting a negative in front. I'm taking 3, 2, 4, 1. What's my determinant? Main minus opposite. 3 minus 8? Negative 5. So my cofactor is positive 5. So I'm going to do 2 times 5. You guys finish it off. Here we go. Finish it off. This is for the end of class. How can you check if it's right? Calculators, go. Have you found a determinant on it yet? Go. You know how to plug in a matrix? Go to your matrix menu with math. Yeah, David has it. Look at him looking out for you guys. You got a new one and it's like Sharpie all over it with a phone number and everything. Go team. Calculator, non-calculator portion. See it, Kyle? If I had chosen some other row, I would just use its signs instead with its values. Do you know? Oh, how I got the negative 5? Remember, it's main, AD, minus opposite, so then 3 minus 8. Negative 5. Am I right? I got 1, yeah? Oh, because 0 minus negative 4. There you go. Now, guys, there are a couple ways of shortcutting this once you get more used to it. And I'll try to show that. But can I show you, since this is a 3 by 3, remember how I said there was a trick for 3 by 3s that you could use? Only works for 3 by 3s. This process will work for 3 by 3s, 4 by 4s, 5 by 5s. But remember, as you get bigger, all of a sudden the determinant of the minor gets harder. Or finding the minor, which is a determinant of what's left from ignoring the nth row and the nth column of whatever term you're looking at. So even though it gets harder, it's still exactly how you would have to find a determinant by hand. There is a trick, though, for 3 by 3s. I want you guys to go ahead. Let's see if I have it already copied. Nope. Oh, hey, it works. Nope. Okay. Give me this matrix. What is it again? The A that you guys just solved. 0? 0, 2, 1. I know that one. What's next? 2. Thanks. Now what? Okay. Whew, that was rough. Probably shouldn't be so loud. Question. A 2 by 2, don't you do main minus opposite? Why is that really bad for a 3 by 3 if you just do main minus opposite? You leave guys off. But check out what you can do. Zero times 2 times 2 is 4, times 4 is 16. 1 times 3 times 0. Main minus 2 times 3 is 6. 6 times 1 is 6. 0. 1 times negative 1 is negative 1 times 4 is negative 4. I used them. I rewrote the first 2 rows, and I got my main. I used everybody. And I'm using the 3. I mean, I'm not using them here, but I'm using them over here. So main minus opposite. But it only works for 3x3s. It's pretty cool that it works, but it only works for 3x3s. Well, probably if you think about all the different minors, like all the main opposites, they probably figured out from all the different, like the main idea of any formula is to generalize. So if they did like A, B, C, D, E, F, G, H, I, and if they went ahead and did like all of the expanding by cofactors process, they probably figured out it would be the same thing as doing this process. Anyway, cool, but only 4. Bummer. Okay, so since it only works for 3x3s, we got to go back to the other way. And the other way says, you know what? You can do all sorts of different things. Meaning, you can use the expanding by cofactors process, but you can choose any row, any column, and to demonstrate that, some of the problems will say, hey, do it using this and using that to prove to yourself, yes, it wants to prove to you that it's true, that both ways will solve for the exact same determinant. You're like, I don't need anyone to prove it to me. Well, too bad. So, using row 2, using row 2. Okay, for letter A, I'm going to go ahead and have you guys show it step by step once again to make sure that we understand it. Using row 2, I would use this guy, right? I would use this guy and this guy. That'd be using row 2. How would I find its cofactors? Now, hold on. Instead of doing all the C's and the notation and the formulas, can I show you just the, once you understand the main idea, here's how you always solve. Is that okay? Determinant of A is going to equal the term 6 times the placement negative times the determinant of, so I have the term, I have the sign for the cofactor, and then I have the 4, 2, negative 7, negative 8. I'll get there in a second, but that's my first piece. Plus, what's my second piece going to be? 3, good, with a positive. If you want, we could group that together. Positive y, because it's in the positive placement, times plus negative 1, right? Maybe this is a little better if I do it this way. Yeah. There we go. So you can see the sign, you can see the entry. Okay, anyway. Negative times 1, and then we have negative 3. What's left to do? Lots of little baby determinants. Main minus opposites. Negative 32 plus 14. There you go. Negative 32 plus 14, yeah, right? 24 minus 8. Good. 21 minus 16. Minus 16. Positive 21 minus 16. Guys, do you see all the mental math involved? Careful. And if you need to write it out, write it out. Yeah? Because what's the dilemma? If you had your calculator, would you even be doing the determinant this way? Mm-hmm. So this could be on the non-calculator portion of the test, which means you couldn't just be with every fact. Just be careful. Be careful of the mental math. Okay. So we end up with 84108, right? Plus 48, I think, minus 5. No, 21 minus 16, I think would be a positive 5, right? Oh. I end up with 140, 56, 151, I believe. How can we double check? Calculator, that's no fun. Or do it another way. Hey, it tells me to anyway. Letter B. It says to try column 3. Now, I'm not going to rewrite the matrix 3 times. Let's see if we can kind of do it. I'm taking off the training wheels little bit by little bit. Let's see if we can do it without rewriting it. Sound good? Okay, who's my third column? Right? So it's in the positive placement for, the positive placement for 2. So I'm going to have a positive times 2 times. Okay. Eliminate row, column. What do you have left? Okay. Now I'm going to do a negative, because of the placement, times 1. Eliminate. Negative 3, 4, 4, negative 7. I'm going to do a positive times negative 8. Negative 3, 4, 6, 3. Good thing we have a second day. But do you get the idea? Nice. Start homework. Bye. Happy nutrition. I'll see you guys later.